Today we're talking about critical numbers, specifically how to actually find critical numbers or critical values of a function. In this case, I wanted to show you an example of what you need to look for, what the actual process looks like, and what things you should be thinking about as you work through a problem where you're trying to find the critical numbers of a function. By the end of this video, you should be feeling a lot more comfortable with how to find critical numbers or critical values of a function. So if that sounds good to you, be sure to stick around to the end of the video. And without further ado, let's go ahead and jump into the example and I'll show you what I'm talking about. We're just going to be finding the critical numbers of this function here, f of x equals x cubed plus x squared plus x. So in general, when you're trying to find the critical numbers of a function, there's going to be two things that can cause a critical number to exist, or basically two kind of conditions you want to look for of which x values would be considered critical numbers of a function. The first is going to be wherever f prime of x equals 0. So basically you need to find the derivative of the function and set it equal to 0 and solve for x. The other one, which is equally as important, although I will admit it comes up less often, but you do still always need to check it, because if you don't check it, you might miss some critical numbers, is going to be wherever f prime of x does not exist. So you always want to be thinking whenever you're doing these critical number examples, which, in either case, what you need to look at is the derivative of your function. So in general, you're always going to start these critical number problems, or any sort of a problem where you have to find critical numbers of a function. The first step is always going to be to find the derivative of your function. That's basically where you're always going to want to start. Then from there, we'll think about how to actually use that to find the critical numbers. So first of all, to take the derivative of this function, in this example, we can just use the power rule. So we can bring the 3 down in front, leave our x as x, subtract 1 from the power, leaving us with 3x squared for this first term. Then the derivative of x squared, again, can be power rule. We bring the 2 down in front, leave the x as x, and then minus 1 from the power. 2 minus 1 is just 1. X to the first power is just x. So I'm just going to leave that as 2x. And then the derivative of x is always just going to be 1. So here's our derivative. So now there's two things we need to think about. Where does our derivative equal 0? So the first thing we want to do is set this equal to 0. Okay. And the other thing we want to think about is, where does our derivative not exist? Where does this function right here not exist? Well, let's think about what this function is. This is a polynomial, right? 3x squared plus 2x plus 1 is an example of a polynomial function. Polynomials exist for all x values. They exist for all x values. They're continuous for all x values. Their derivative exists for all x values. This right here was a polynomial. The derivative of a polynomial is just going to be another polynomial. So this derivative here, this f prime of x, there's not going to be any x values where it does not exist. So in this case, we don't need to worry about this condition because it exists everywhere. As a result, we really just need to worry about this one. But like I said, you always want to think about this condition here. You always want to think about where your function's derivative does not exist. In this case, we're just going to have the solution to this equation, though, giving us our answer. So we need to figure out if there are any x values where 3x squared plus 2x plus 1 equals 0. So how could we try and figure that out? Well, typically the best place to start with a polynomial like this, setting it equal to 0, is to factor it out. How can we factor this out, though? Because we have a bit of an issue here where, if you kind of think about the ways that this could factor out, basically we need two numbers that multiply to give us 3, which is going to be 3 and 1. There's not any other ways to factor that out. And then we need two numbers that multiply to positive 1. So that would just be 1, positive 1 and positive 1, or negative 1 and negative 1. So really we only have two choices here. We could either say plus 1, or we could say minus 1 and minus 1. Let's think about how those would end up factoring out, though. If we were to kind of reverse engineer this, we would get 3x squared, so that's good, and then negative 3x minus x would be a negative 4x, not a plus 2. Right? So that's not going to work. And then similarly, if we were to put plus 1s here, we would get plus 3x plus x. So that would be a plus 4x. So there's not going to be a way to factor this out like this, which is kind of a bummer. That's generally going to be a lot easier if you can do it. But it's not the end of the world if you can't do it. The other option is to use the quadratic equation. So let's go ahead and do that. The quadratic equation just tells us that we're going to have x equals, so negative b, so there's a little song that kind of goes along with this. I always have to kind of sing the song in my head. The opposite of lowercase b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of lowercase b, where this coefficient is a, this coefficient is b, and then this constant is c. The opposite of lowercase b plus or minus the square root of b squared minus 4ac all over 2a. So let's think about how this will simplify here. We're going to get negative 2 plus or minus the square root of 4 minus 4 times 3 times 1 is 12. So without even going further, you can see right here, we're going to have 4 minus 12 within the square root here, which is negative 8. So we're going to have the square root of negative 8. Well, that's a big problem because you can't take the square root of a negative number. So whenever you have a negative in here, that right there tells you there are no roots here. There are no real roots. There's only imaginary roots. So basically there's no x values that make our derivative equal 0. So in this case, you know, we're kind of running into some issues with solving this this condition of taking the derivative and setting it equal to 0. We're not going to get any like real x values that cause that. Basically what this tells us is that this function here does not have any critical numbers. There's no places where the derivative equals 0. There's no places where the derivative does not exist. So this function actually does not have any critical numbers. And that's really it with this problem. There's really nothing else we can do there. So that's going to be the final answer for that one. That wasn't too bad, right? Hopefully you're feeling a little bit better about finding critical numbers of a function. In this case, we went over a polynomial, but really the process is the same no matter what type of function you're going over. If you did get some value out of this video, it did actually come directly from one of my weekly live streams, which I do every Monday night at 5 o'clock Pacific time. So you'll probably find those pretty helpful too if you like this one. I usually go over a few different examples and I'm available to answer questions live if you have any questions along the way. So go ahead and put it in your calendar and hopefully I'll see you next Monday night. Thanks.